In this lesson, we are going to continue talking about identifying proportional relationships and some other examples. Using the table below, analyze the cost of downloading applications to a phone. Looking at the table, we can see that if we download 2 apps, it would cost $6. If we downloaded 4 apps, it would cost $12. If we were to download 5 apps, $15, 6 apps, $18, and 10 apps, $30. Let's analyze this table. How can you find the ratio of the total cost to the number of downloads? Remember, a ratio is comparing two things. So in this question, we are comparing the total cost to the number of downloads. In order to find this ratio or this comparison, we divide. And for this example, we would divide the total cost by the number of downloads. So let's look at that. What is the ratio of the total cost of the number of downloads when you download 2 applications? So the total cost for 2 applications is $6 to 2 applications. Well, what about 4 applications? The total cost for 4 applications is $12 to 4 applications. 5 apps is $15 to 5 applications. Remember, we're getting all of this information from the table above. Go ahead and pause the video and write your ratios for 10 applications and 6 applications. For 6 applications, the total cost is $18 for 6 apps. And for 10 apps is $30 for 10 apps. The main thing you need to remember when writing these ratios is writing it in the order the problem is asking. The problem specifically says, what is the ratio of total cost to number of downloads? So your first number should always be the total cost, and then your second number, the number of downloads. And your problem will always verbalize this to you. Number 4 wants to know, are the data in the table in a proportional relationship? If so, what is the constant of proportionality? Remember, to determine if it is proportional, when we divide, we should get the same thing throughout every ratio. So let's look at each ratio. 2 applications, 6 to 2. 6 divided by 2 equals 3. 4 applications, 12 to 4. 12 divided by 4 equals 3. 5 applications, 15 divided by 5 equals 3. Go ahead and pause the video and check to see if 6 applications and 10 applications also equal 3. 18 divided by 6 equals 3, and 30 divided by 10 equals 3. So yes, this is a proportional relationship. And because it's a proportional relationship, it has a constant of proportionality. And remember, that constant of proportionality is the same thing as the unit rate. So it's the same thing we get when we divide. And when we divided, we got 3. So yes, it's proportional. And because it's proportional, the constant proportionality is equal to 3. Now I want you to look at 5 and 6. Pause the video and answer the questions. Number 5 wants to know if the quantities in the table are proportional. The table shows the number of hours needed for different numbers of people to clean up after a school dance. Are the quantities in the table proportional? When I look at the proportions, 12 divided by 2 equals 6. 9 divided by 3 equals 3. 8 divided by 4 equals 2. And 6 divided by 6 equals 1. So when I divide each ratio, I do not get the same thing. So no, they are not proportional because the ratios are not equivalent. So remember, for it to be proportional, all of your ratios must be equal. So when you divide, you must get the same thing. Number 6, the students in the service club are mixing paint to make a mural. The table below shows the different parts of paint that the students mix together. 2 mixtures of paint will be the same shade if the red paint and the white paint are in the same ratio. How many different shades of paint did the student make? The student made 2 different shades of paint. The ratio of white to red is 3-1. And that was for A, D, and E. And then the other one is 2-1. And that one is for B and C. So when you look at the ratios, let's look at A, D, and E first. So when we look at those, we're comparing the white to the red. So for A, white is 3, red is 1. So 3-1. 3 divided by 1 is 3. D, again, white to red, 6-2. 6 divided by 2 is 3. And then E, again, white to red, 9-3. And 9 divided by 3 is 3. Then when we look at B and C, and we look at those ratios, we're still looking at it white to red. So for B is 4-2. 4 divided by 2 is 2. And C is 8-4. And again, 8 divided by 4 is 2. So the 2 ratios in this problem came out to the 3-1. 3-1 when we divided for A, D, and C. And 2-1 when we divided B and C. We just had to remember to divide it white to red. We're comparing white to red. Now let's refer to the situation in problem number 6. So the shades of paint. Which shades of paint are the most red and why? So remember, we had 2 mixtures. we had a mixture that was 3 to 1. And we had a mixture that was 2 to 1. And remember, this was white to red. So between these two mixtures, this problem wants to know which shades are mostly red. Pause your answer or pause the video and think about what your answer would be and why. Mixtures B and C would be more red. So remember, mixtures B and C had the ratio of 2 to 1, which contained more red paint. Than the other mixture, which was a mixture of 3 to 1 for the A, D, and E mixtures. So B and C, mixtures B and C would be more red than the other ones because they contained more red paint. Because remember, we talked about them compared from white to red. So 3 to 1 had more white paint than the other one, which would make it more pink. Use the table in problem 6, so we're using that same problem, and plot a point for each ordered pair. After you plot each point, draw a line connecting the point to 0, 0. So in the previous lesson, we talked about looking at these proportions on a graph, and we can do that by plotting points from the table. So we're going to start by plotting our first point at 1, 3. So if we have 1 part of red paint to 3 parts of white paint. So remember, that was our mixture. From the table before, that was mixture A. 1 part red, 3 parts white. The next point I'm going to plot is 2 parts red, 6 parts white. 2 parts red, 6 parts white. And again, this is from our table. And then the next one I'm going to plot is 3 parts red to 9 parts white. And then again, all of this is from our table in number 6. And I'm going to connect those and going through the origin at 0, 0. Now, you might ask why I only did those 3. So, if you remember, those 3 from our table were A, D, and E. The ones that had the 3 to 1 ratio. They shared the same ratio. So I plotted those on the same line. So we can do another line to show the relationship between B and C. So the 2 to 4 and 4 to 8. So using those same points, 2 parts of red to 4 parts of white. And then 4 parts red to 8 parts white. And those were the only 2 ratios that were the same. And then we can connect those, again, meeting at the origin, and then continuing. So we wanted to put the points that shared the same ratio together. We wouldn't be able to plot all 5 of these together because remember, for it to be proportional, it has to make a straight line that goes through that origin. and altogether those 5 points don't. But we can look at them separately and group them into proportional relationships. So based on the graph, what do the mixtures that are the same shade have in common? What does this tell you about their relationship? Pause the video, take a look at the graph, and write your thoughts down on number 9. So like we discussed, the points in the same proportional relationship lie on the same line. And both go through the origin, because they're both proportional relationships. So they're both going to go through that origin, and they're both going to be a straight line. They're just two separate straight lines because I have two separate proportional relationships. So let's look at it another way. Work with your groups. So we're going to talk about that together and determine whether the equation represents a proportional relationship. Explain your choice. You may want to make a table similar to those in problem 5 and 6, or a graph similar to that in problem 8 on a separate sheet of paper to support your answer. So looking at these two equations, we want to know if they represent a proportional relationship or not. And based off what we've done so far, you can make a table or a graph to help you represent this. So what that might look like is if you have a table of values, and if you look in the equation, you have an x and a y. You can pick the values you want for x. So we could just say 1, 2, 3, 4, 5. And we can use that equation to determine our values for y. So we can evaluate and plug those in. So if x is 1, we could say 2 times 1 is 2, plus 4 is 6. So I just replaced x with 1. And then I solve that equation. And then I can replace x with 2. So I can say 2 times 2 is 4, plus 4 is 8. And the same thing for 3. 2 times 3 is 6. 6 plus 4 is 10. And then I can do the same thing for 4. 4 times 2 is 8. 8 plus 4 is 12. And the same thing for 5. 5 times 2 is 10. 10 plus 4 is 14. So now I have a table of values like we did in the previous problems on 5 and 6. So I can look at those table of values and I can divide to see if they have the same constant of proportionality, to see if they're proportional. So when I divide this first one, 6 divided by 1, 6 divided by 1 is 1. Or 6 divided by 1 is 6. When I divide the second one, 8 divided by 2, 8 divided by 2 is 4. So I get something different. So I automatically know that no, it's not proportional. Because when I divide, I don't get the same thing. I don't even have to continue dividing the other ones. As soon as I get one ratio that's not the same as the one before it, I know it's not proportional. So go ahead and pause the video and try number 11. Make a table like I just did for number 10. You can use those same x values, But when you plug those x values in, you'll get different y values. So you'll get different values where it's pink. So make you a table and decide if number 11 is proportional with the video paused. So yes, you should have found that number 11 is proportional. If you did not find that it is proportional, make sure that you send me a message or ask in our Google Meet to go over why number 11 is proportional.